So hi everybody. I'm Tiziano. For those who has not been to our Fab Lab, I'm like a technician, design engineering, and I started working more in the letting people in the Fab Lab, teaching them how to use the machine. But right now I switched more to engineering project. So I'm the one where to ask if you have a very complicated question, but usually I'm not the front man of the lab anymore. And was a very nice period, but was very difficult to work on my project actually. So right now I'm more able to focus a bit more on the design part of our lab. And I'm working both for OpenDot and .dot. So we are kind of mixed at the moment. So each one of us sometimes work for .dot, sometimes from OpenDot. .dot, for those who doesn't know that, it's a design studio that works a lot with interaction design. They started with the exhibition for museum, so interaction exhibition, and they switched with time also in some part with the service design and some part of digital experience on the web. And nowadays they're trying a bit to work with digitalization of the experience for museum, because in this moment it's pretty difficult to work on a standard museum. We are opening up some exhibition that actually are not designed at all for this COVID situation, because we liked a lot to work with tangible interaction, so something you can touch, and at this moment it's not the right choice, but we hope this situation will stop soon. And so I'm starting to present my screen. I have a very quick presentation, and it's very quick because Antonio had talked a lot about designing last time, and I think he made a pretty good presentation. So I just want to talk a bit more about just one tiny aspect of those kind of design we make with this kind of tools. So the one that are really specific for one user need, and just to put the focus on that. And then we will talk just a bit about other 3D scanning system, because today we are using Photogrammetry just because it's the easiest tool you can have to use it at home without any other technology than a photo camera and a computer. So we were thinking was something interesting to do in this time that we are everybody at home and we cannot meet all together to use a technology that is here. And so we will talk a bit about photogrammetry software after that. And the most difficult thing about using photogrammetry in a proper way, actually, it's not using the software, but it's making a good photo dataset. That's the hardest part, actually, because if you don't shoot a proper dataset, your project will be useful, and you need to shoot everything again from the start. And also using photogrammetry for the human body, it's a bit more complex than with the static object. Then at some point we'll make a break. I don't know exactly when, but I think in maybe 1 hour and a half we will make a break. And then we will start with the mesh modeling software, which I'd like to spend a bit more time after the 3D scanning. and because there are a lot of different techniques, and I want to go a bit more in depth with that. I'd like those you can to actually use the software during the presentation. So if you manage, I would like that, and I know they're pretty resource-consuming software for the for your computer, so it will be maybe difficult to use them while you are in a video conference, but can be a bit really resource-consuming, especially Meshmixer software. It's really hungry on the RAM of the PC. But you can try to use it, and I will explain how to keep that light. So try not to be too heavy on your computer. And if you don't manage, don't worry. We will just follow my screen, and that's it. But I think it's really good and better to learn the software using that. And you will be able to remember a lot better, and then you can ask a proper question later. And that's it. At the end, if we manage, we can also talk a little bit about 3D printing, if we have still some time. Because it's becoming a really interesting technology for medical topics, and maybe will join us also Mattia Ciurnel. It's not here yet, which is a guy that has done the Fab Academy here, and is now working on a WASP Hub, which is a 3D company that is from Ravenna, and he's working here in Milan in a 3D print shop. So maybe he can tell us a bit more about 3D printing with FDM machines. Okay, so this is our space. I need to do a very quick introduction about us for those who doesn't know. I'm actually here upstairs, if you can see the stair on the second room, and it's very hot. And this is a guy that was doing here the Fab Academy. So however, it's a place for making, so we have different technology, and the things I like that about this technology is you don't have to be a good artisan to make stuff. So you just need to think as an artisan, but this kind of technology like opens the world of making also to people that are not very good to use things with their hand. So it's kind of opening up this this way that was before just for people that were really good in making stuff with their hands. And so you just need to know the machine and design stuff well, and you can switch from the computer to the milling machine or to the printer without any problem. And thank you, Daniele. They're bringing me some food for later. Okay. And so all the technology we have works mainly with the bidimensional or three-dimensional file. And it's also a place for learning. And we like to say that we are not just teachers, but we are also students. So if you come by to our lab, we will probably learn something from you. That's the reason the lab is open. And so it's a place where you learn by your peers and from the other guys that comes to the lab. And it's a place for research. And we like to put that research into practice. So actually make the things works to see if they're good or not. And we like to to make them work as fast as we can, so we can see if there are errors in the design process. And we believe a lot on co-design. So all of our internal team are made by people with a very different mindset and abilities. And but we are not just including diverse people inside the team, but we are also working with the user, the final user. So in a typical co-design process we make in the healthcare system, we are mainly working a lot with TOG, which is the foundation from that helped us to make this bike. And the bike is for Lorenzo, which is it's a TOG children, so it is having help inside TOG. And so we include the therapist in the process, not just designer, and the final user. So all together we can design something that fits the needs of Lorenzo, and it's designed properly from the medical perspective. So it has the right ergonomics and so on. And this is about me. And as I was talking before, I make mostly design engineering, studying and testing stuff, but most of the time getting covered with the sawdust from the milling machine. Also Alberto, it's in the same kind of situation usually. And in this presentation, I just cut away the last two chapters I was intended to talk, because we will probably talk about that later in the hands-on part. So I would prefer to do them in practice. So why we are doing this? As a designer, most of you are designer in some way, and we learned how to design stuff for the average man. So I took this slide from with so many others from Antonio's presentation, because I like them, the reference a lot. And in this period, I think around the 60s, 70s, maybe, not sure about that. In the design system was introduced a lot of ergonomic studies, and they tried to make more standard and readable as possible, which is really, really important piece of work if you are a designer. And I'm not denying that it's really, really important that every designer study a lot ergonomics and so on. This approach was intended to make a design for all kind of practice. So it's a way where you design for the biggest number possible of people to use your product. Okay, so this is a Gaussian curve. So it's a curve that you will see in every kind of random distribution. So with the people sharing the average dimension standing in the middle, and the most of them has that dimension. And if you go far away on the curve on one side or the other, you will find the taller guy and the smallest guy and so on. Those two parts of the curve, the 5% of the user that it's in the yellow area, it's usually ignored by designer. That's because the design for all approach, it's kind of utopia. So in some case you will get that, but there will always be a guy that it's around here or around here, which is left over in this graph. And also another problem is when you design something to be the widest possible, sometimes works a bit less for everyone. So it's something that it's like very generic kind of style of design, and maybe the performance for each user it's not perfect in some way. And so what we are trying to do today, it's design just for this guy here. And this is the design for each approach. So we just are choosing one specific person to work with. The problem of this design approach, it's mainly the cost. So why we have done this for decades, it's because we are using industrial production, which is mass producing our stuff in order to get the cost going down. So we are making miniature molding and a lot of technology that are designed to produce one part every 2 seconds, fraction of a second, and so on. And the cost of each component, it's very, very low. So one plastic part can cost 10 cents or something like that. If it costs €1, it's probably a too high price for some product. And in our design for each part will cost more in the €10 range, €100 range, and so on. So it's the design for each has a higher cost. So what we are trying to do as a Fab Lab right now, it's trying to scale up the design for each approach. So we are trying right now with Antonio and others in the team to make some parametrization website. So a place where you can order products that are designed just for you. So they're designed for like a broad spectrum of disabilities, like the glypho you were working on in the Antonio lesson. It's a parametric design that can be adapted. So it's just one design, but can be made in every different dimension. Today, we are following a different approach, which is designing on the mesh that we are obtaining from the scan. So it's designing just for that shape. But it's possible to kind of scale up also this process. So we will see a lot of different tools because they are kind of experimental stuff right now. So photogrammetry, it's becoming far more popular in the latest few years. So we are seeing a lot of well-done software like Zephyr we are using today. It's a pretty good one. It's the nicer free software I've seen until now. And those will permit us to get our scan, but it's still a work that it's to be done in some way manually. So for each person you are doing a 3D scan, the modeling operation will be just one-time operation. But maybe with the rhinoceros grasshopper, it's possible to kind of make some automatization about this design operation and make them automatic in some way. So the designer part will be just maybe draw some line where I want the color to be, or my mask to be around the face, and then the software will do the rest automatically. So take each of the operation we are doing as like a building block that in the future will probably be put together in a automatic software for medical technician or so on. So we have seen during our research a lot of automatic software to do, for example, the dental implant that Alberto was teaching about the previous lesson. So what they're doing, it's not making a completely new software, but just make a bundle of different function that you can put together to make like a standardized operation. So every time you get a 3D scan, then we design the dental implant that go from here to here and so on. So today you will learn more about more generalistic kind of software, but in the medical situation, usually they buy a suite of software that just does that operation. So in that way, the operation will be speeded up and will become probably part of the medical standard operation. This slide was, I talked about much about the previous one, so it's a bit of far off topic, but what I want to say about this, it's in the design spiral process that Antonio already talked about. So we are trying to make the first prototype as soon as possible in order to validate, develop new plan, and so on. And every time we do like a turn around this, we will talk with the therapist, the user. We will make tests and so on until the product is satisfactory for the user. So especially in first time when we are doing the first glypho or the first bike, we are doing a lot of this turning around and talking with the specialist during the design process. So what I want to say, it's today you are talking to a designer, and I will not never design something as we are doing today without talking to a medical personnel or a therapist or so on. So we never design by ourselves as we were doing today. Okay, so today we are just learning a tool. I'm not trained as medical person, so I will probably do something wrong. And it's good like that. We are just testing the technology today. Okay, so in this second part, we will talk about 3D scanner, because there are a lot of different one, and I'd like to just see just a bit the difference between them and see how each one of them is better for some kind of situation or not. Okay. So this is a kind of tree of technology, which is the first one. It's I just put it there because it's nice to know that at the beginning 3D scanning was done sometimes in a destructive way. So one of the first 3D scan of a body was done freezing a dead body inside a container, and then actually take slice out of it, and just bidimensional scanning or drawing each slice. Okay, so that was the history of tomography. Okay. So,
a human body?
A human body, not a living one. Yeah.
Tiziano mentioned that actually the experiment was firstly conducted over over convicted people after suffering capital punishment.
Yeah, and actually they didn't know what their body was going to be later. Yeah, they like signed, okay, you can use my body for medical whatever stuff you like to do, and they were actually cut in tiny slices. And so that was the first kind of 3D scanning of human body. And so tomography actually means writing and stratus, actually. Another kind of very different technology from the one we are seeing today, it's contact scanner. So it's like touching every point you need to measure to get a proper scan. This is used a lot in the industry, but actually you're not making a really complete 3D scanning. You're just touching some point that you need to check for tolerances. If you want to do a complete 3D scan with this system, you can do that actually, but will take probably days to complete the scan. So the machine is just going every point until it touches the surface and so on. The machine needs to already know in some way the shape of the object in order to go a bit faster. And so you are just checking the dimension actually. Another kind of 3D scanner that it's being used a lot more in these days, it's time of flight kind of a scanner. Time of flight means you are pulsing a single shot of a laser and measuring the time before the feedback comes back. So the lights goes on, hits something, and then comes back, and you measure the time that it's that has traveled, and then you know the distance of that point. If you do that with an arrow of string, like an array of string of laser, and you scan pretty fast, you will know in real time how is the world around you. And that's the technology of one of the technology that it's used on the vision for autonomous car. So an autonomous car will see the world around that like in this way. So this graph is showing from the center point of the 3D scan, which will be probably somewhere here in the center, or in the probably in the tower here in the center of the this place, and you will see like a depth map that say all these points are in this distance from the viewer. And this kind of scanner, it's usually used inside buildings, for example. So you can place your camera on a tripod to get a scan of the room, then move the scan in another position and do another scan. And then later you have to align the different point clouds and put them together, and then make a mesh after it. So today we will see in some software we are getting point clouds. We will do the mesh just after that, but know that if your scan is not satisfactory, you can make a lot of different scans and put them together to get a better scan with more data inside, because it's like standard procedure in 3D scanning. And another very useful kind of scanner, it's a triangulation scanner. Usually it's done with one line of laser or more than one. And you're just looking from a different angle from the point where the laser is going. And one important stuff, you know exactly the baseline from where is the camera and where is the laser. And you know exactly the angle between camera and the laser. So knowing this, you will be able to get an exact measurement, okay? So it's kind of different from the time of flight concept, and it's based on just sine and cosine formula. So it's pretty simple, mathematically speaking, and it's very accurate. So it's a bit more accurate than other 3D scanning system, and so will be much useful to make like a scan of object with tiny details. If you want to do that with a photogrammetry machine software and kind of setup, it's fine to make a 3D scan of a very small object. You just need to be prepared to do macro photography kind of setup. So it will be a bit more difficult to get a photography of a small object, everything on focus, and so on. This kind of 3D scanning, it's more slow than photogrammetry. So photogrammetry, it's a slow process, but we will see there are some way to make it fast. And triangulation scanner remains a kind of a slow technology compared to other one. And the object is usually put on a turntable and will turn during the scan. So this is pretty difficult to do with a human. So imagine to be on a stool that turns really slowly and be asked to stand very still. Will be really, really difficult to do that. But other kind of triangulation scanner may work on humans. So there are others one that make a pretty fast sweep of laser like this, and the camera is on another position. So they're able to make a scan in like a few seconds, but are a bit more rare kind of scanner. This is a kind of scanner that I really suggest for designer, because it's the best one to get a proper scan of object without, let's say, interesting feature on the texture. So if you have like an object like this object here, it's completely flat here and doesn't have any feature on top. So will be pretty impossible to do on photogrammetry. So photogrammetry, just look for different texture you have on the object. So we'll look for a specific feature that it's kind of different from the other, and be able to make a description, mathematical description of each feature, and be able to recognize that feature in different photograph. So photogrammetry will be useful for some kind of 3D scanning, but will not cover all of the 3D scanning situation you will face. And so it's just useful for objects with texture that are not repetitive, because repetitive texture can fool the photogrammetry software, and so on. So for those kind of objects, the most object without a texture or a specific feature on top, the best scanner you can find are structure at the light and triangulation scanner. They are both triangulation scanner in some way, because they always have like an angle between projector and the image capture device. And they have a measure baseline between the two. The structure light scanner 3D, it's a similar version to laser scanner, but instead of projection one line or one point of the laser, you are projecting a full image with a projector, and this image goes on a 3D shape and takes wraps around the 3D shape. And how it's able the software to recognize the shape of the software, it's because they're projecting a lot of different patterns all together. So the first pattern will be just a division between the space in two parts. So I'm projecting an image that is black on one side, white on the other. And so I'm saying all the part of the object that lights up will be on that part of the projector area. Then I'm dividing this area in two again, and I'm saying all the previous pixels that were in this position now are on this other slice, and so on. So this way, I will know which part of the projection falls on each part of the object, right? And then I'm able to reconstruct each point of the projection. Okay, so it's a bit more complex, but if you're interested in, you can look a bit more for this kind of 3D scanning. Both of them, the triangulation with the laser line and this structured light are really good for object that doesn't have a texture, but they should not be reflective, mirror finish, or transparent object. So each of the 3D scanning, technology, also the time of flight, all the non-contact 3D scanning will use probably light as a source for the scanning, so will not work on transparent glass material or reflective one. So be careful about how your object is done, what you're scanning, and so on. And but there are ways to avoid those problems. So you can cover your object with dust or whatever to smooth out the glossiness in some way. So then you are able to use again triangulation and structured light and also time of flight scanning. And then if you want to use also those objects for photogrammetry, you can put marker and texture on top of the object. And you can do that also with a projector on sometimes. So sometimes when they scan people with the photogrammetry, they project some pattern with the unique feature on top of the person. So there are a lot of ways to avoid those kind of problem, but remember, you're using light to get the scans, so think about that, getting proper exposition on the photos, whatever. And so you need to think about a lot about how to get proper image. Getting a bit more in depth with photogrammetry, what we will see later on our data set, it's that we need a lot of similarities between the photograph. So for making a scan of a person, we cannot just take 4 photos, one from the side, one from the back, one from the front, and so on, because we need a lot of similarities between the photos to be able for the software to recognize that one feature it's on this photo, also on this photo, also on this photo. So we need the photo to be at least half of the photo need to cover the same area of the scan I'm doing. So we will see later, will be a bit more clear in the data set that we will use what I mean. And the other thing we were saying, it's we need a lot of texturing on the photogrammetry dataset. So photogrammetry, it's really, really useful on natural object. So like if I'm scanning like a terrain, like in this situation, or I'm scanning a human body, I will have a lot of tiny feature for the software to look at it. Okay, and very unique feature. So I will not have I don't know, a spot of my skin that it's similar to another spot. Okay, so they're all unique, all different, and it's what photogrammetry likes in some way. Okay, last but not least, all the 3D scanning that Alberto has already talked to you in the previous lesson, it's actually 3D scanning. So it's very useful to, in the medical operation, to be able to use this kind of scan. And the only problem with this kind of system, they are really, really expensive. So will be really, really difficult on a project to be able to use them. So if it's not really, really mandatory for a person to get a tomography, usually it's impossible to get a tomography because the scheduling on this machine, it's really tight. For 10 minutes, they're doing a scan on a person on a limb, and then the other 10 minutes later, you're doing a scan on another patient, and so on. They're fully booked day and night usually. And so if you're doing a project which is not life-saving, it's pretty difficult to be working without tomography, actually. But if you're working in an hospital and actually you're doing this kind of life-saving project, maybe this kind of 3D scanning will be the part of your job. And as Alberto was saying, being able to know exactly what's going to happen during the time that the patient is inside the medical room will be not just life-saving operation, but will be money-saving operation. So it's really important also for hospital to invest on this kind of technology, because they're actually saving a lot of money making this kind of research operation. And so on. I just put some random picture of really diverse kind of application of the software we are looking today. So for sure, medical operation, we are talking about that, and we know there are a lot of innovation going on this kind of topic, but I'm putting also very different kind of stuff, because it's interesting to see different application for this kind of stuff. So we can also look at design art to see some kind of application of 3D scanning with design. So those are design art kind of project. It's Modern Soul Tools by, I cannot pronounce the name. You can read them. And this kind of project is done using photogrammetry or laser scan triangulation. So as you can see, the design mimics really well the object they are attaching to. So it's the same stuff we will do today in some way. So in this kind of project, we can see that the design operation is done in 2 different steps we will see today. So if you have already Fusion 360 installed, we will see for a very brief moment how to make the 2 software talk properly. So we will just see how to import stuff from and back to Fusion if we need them. So this kind of operation can be done pretty easily, designing, having already the stone on 3D scanning of Fusion. Then you can model the part of the object which is like more design-like. So it's with primitive kind of feature, and more I don't know, like designed in a traditional way, and then having the part that it's mixing with the object shape done in Meshmixer or a software like Meshmixer. So you can blend all the tools together to get some parts that are designed in a more standard way, and some parts that are designed in a different way, more mimetic kind of design. Another application for photogrammetry, interesting one I've seen, because I go climbing sometime, and it's really, really difficult to have a proper map of what you will see there. So to know where is the route I need to follow or whatever, usually you have a very bad design made by one person looking at the crag and designing the crag manually, and you go there and you look at it and you see it's completely different. So you will not see where to go or whatever. And so they're making 3D scanning with a drone to get the shape of the place, and then they draw manually on top of the texture all the routes that you can go and find later. So if you are interested in, you can see this experimentation on this link. I will send you the presentation later. And another very, very interesting operation, it's this, I think it's experimentation from Meet Media Lab, if I don't remember well. And it's experimentation with Stratasys. I'm not sure about that. So it's a big 3D printing company on how to use directly the data from tomography to make a 3D print that it's using voxel instead of meshes to get the 3D print. So it's pretty difficult concept. So when we are designing nowadays, because it's kind of changing for some tools, we are just designing the surface of an object. With the tomography, you actually get voxel from the 3D scan, which are a different concept. So you're making a lot of different slices. Each slice has some pixel. If you have the pixel size, which is the same distance between the different layers of the scan, you're actually getting a lot of voxel that are, in this case, square, but they can be also with different shape. If the scan are not at the same distance as pixel size, we will get a voxel which is more parallelogram. And then you can use this data. You can modify that. So this 3D print was done to show the bones inside the hand. So they removed everything that was not bone. So all the muscle and other components of the hand was removed by the 3D scan, and then they just print this data without making the mesh. So they are just printing the different densities of the bone. So if it's not dense, it's transparent. If it's more dense, it's more white. Okay. So this is a way to treat this kind of medical imagery in a different way. And this kind of 3D printer will be really useful also for design purpose in the future, because they are able to produce part that has a different degree or flexibility or transparency or whatever, and those can be used in design too. So for the moment, we are like in this mouse, we are dividing part to get like the wheel, it's a bit more rubberish. This part is flexible, but not much. And I don't know, these bottom part are done to make more easy to move on a surface. So it's a kind of different properties for the material that will be possible to print just in one time with a machine that can print different material together. So also volumetric way of design. So designing with voxel will be really useful in the future. So what I'm suggesting is you as designer, if you want to stay ahead with the technology, it's better to learn a lot of different tools, because who knows what we will use in the future to design to. So Antonio was also talking about artificial intelligence algorithm. So that's another really interesting kind of future for design. So you will be like a programmer of algorithm that design stuff. And this is also very interesting things for our kind of project. So the project we were talking before, how to speed up a really custom-made design. So I want the user of the object to talk directly to a computer and design the object for themselves. So this is really will be really game-changing kind of application in the design for each kind of process. So if I'm a disabled person and I cannot use a mouse, I still can be a designer of object for my own, and maybe just talking to a computer. So that's really interesting kind of situation. I'm done with the presentation. I've just put a reference here, which is Sketchfab. It's a very interesting website for looking for 3D scan already done. And if you put on there is you can choose to look just for a free and downloadable object. So you can look for a lot of hand scan or something to work with if you want to make a test project and see how it is. But I will suggest you to make your own 3D scan, because it's really strange stuff when you see yourself turning on the screen. It's really nice stuff to see. And so I would suggest you to take the full process. But if you want to look just at the last part of the step, you can just use the data set I've put on the Dropbox link. And you can use them to make photogrammetry and 3D modeling part, or you can just do the 3D modeling the last step, because I've also put 3D models already done from the meshing operation with the photogrammetry, so you can just use the 3D models I'm providing today to make your test, your design, whatever you like. Okay. If you are okay, for the moment, I will just go to see the photogrammetry dataset we are using today, and then we will make a quick break. If you need to still install the software, it's the right time to do. On the Dropbox link I've sent you, there should be a software folder with some software for Windows. We have 3 software, which is Zephyr 3D, Meshmixer, and MeshLab. And for macOS, we have Meshmixer and MeshLab, and Regard 3D for the 3D scanning. The first one we will use will be Regard 3D. We will make just a very quick introduction, and then we will switch to Zephyr 3D. So I was saying we will use Regard 3D, just a quick overview. Then we will go a bit more in depth with Zephyr 3D. Sorry, Regard 3D. Then MeshLab, just a quick overview of the software, then Zephyr 3D, and then Meshmixer. So we will have a lot of different software today, so you will see a lot of different things, but don't be worried. They are actually very, very easy software. So usually photogrammetry has a kind of very guided step kind of process. So actually the most difficult part is making good photos. You will see it's not that complex, the software at the end. And MeshLab, it's kind of the most complex one we have today, but I've used that without knowing anything about mathematics. It's on the back of the software, and they are just they just have very difficult names for the tools you are using, but actually you don't need to know anything about the strange name you will see. And Meshmixer, it's as the name says, it's a very simple software made actually with the children in mind. So you can mesh mix and put Benny hairs to whatever mesh you like. and but on the back has a very powerful meshing algorithms, so will be really powerful software to use. I think that Meshmixer is kind of being left there by Autodesk because they're putting Meshmixer and Fusion 360 together. So Meshmixer was an experimental software that will be inside Fusion later. I'm not sure about that, but seems the way they are modifying their software lineup. Okay, so last part before going inside the software. So this is the first data set we are using, nothing to do with the medical 3D scanning. It's a free data set that it's part of the tutorial with Regard 3D. And it's really small data set. So if you see the image, it's really small. And there are not too many photos, so it's just that. As you can see, it's just a bunch of photos from a slightly different angle. And they're objects with a lot of different features to look at it. So it's really random choice of object. So we have a motherboard, some books, and a Kermit, and a jacket, and a chair. So, but each of these objects has a lot of different feature to look at it, and will be really good for the photogrammetry software to recognize different pattern in the object. As you can see, we need a lot of photos with the same details on it. So the software will recognize the eye, will recognize this button, and see that we have the same object in different photos with slightly different angles. So this is what photogrammetry need at the end. Okay, so now it's we can see another feature. So we need that the same feature. We need that feature to be on at least, I would say, 5 or 6 photos, at least. So the more photo you have, the more time will take the photogrammetry to align them. But the best will be the scan. But try not to overdo this, because the time you will take will be much more. And then maybe you need to decrease the resolution or the quality of the alignment or whatever. So the good part is always in between. So if you take like 500 photos, you will need to make a compromise on some other part of the scan. So what you need to look, it's to be able to represent each part of your scan. Sorry, I don't have anything in there. Okay, so this is more than enough. Forget my face into 3D scanning. I've put some strange marker around my face, and I've been careful to not make the same marker twice. Okay, so that's to be sure that the software doesn't make the same, does not think that this cross is the same as this. It's pretty difficult on people to have this error, because around this marker I have a lot of different other features that make this marker unique. Also, if I've drawn the same exact cross on the other side. But if you are printing markers with a, I don't know, with an inkjet printer, you have exactly the same marker. So it's very important to make them different. So you can find a lot of marker if you look for photo, we will see a lot of coded marker that are unique identifier that the software can look up for. Okay, so those are the proper one. But for our purpose, it's fine to just draw some random stuff around the object. So this is a kind of, and this is Fab Academy actually website, and this is a 3D scan that was made by Photoscan software, and the Photoscan software can generate his own marker. So it's able to recognize those markers, and those help to make the first alignment of the photos. It's actually not needed on all photogrammetry software, and the software is able to identify his own marker without any problem. By the way, if you look for 3D scan made in the, I don't know, the architecture field, or 3D scan made for cultural heritage kind of 3D scan, they used a lot this kind of marker because they're making a lot of different data set. Imagine you're scanning a room and then you want to put together the room with the other part of the building. So in the part where you are going from one room to the other, you usually put a lot of marker, because it's the point where it's most difficult to align the two scan together. So you are using those marker to put a different data set together. So you're maybe getting a point cloud of the room, then another point cloud of the other room, and then you're using this marker to align the two 3D scan together. Okay, so it's a bit more complex than what we are doing today, but knows that this kind of stuff it's used usually. So I'm doing something a bit more rough here. The other interesting things I've started doing when I'm doing a project in some way for the healthcare, it's I design actually what I want to do on my face or on the wrist or whatever. This is a very simple way to be able to design in real life. So if you talk to the doctor with the patient there, and you would say, oh, maybe we need to make the brace going here, and then here we need to put a strap. You can design this stuff directly on the patient, maybe. It's a good way to be able to talk between designer and medical staff and the patient all together. Okay, or you can draw on the 3D scan later and make screenshot and talk to the medical personnel later with the 3D scan. So it's up to the different kind of project you want to make. In this case, I wanted to make a mask that avoid my glasses. So I've drawn this shape with the glasses on top of my face to see if there is a shape that I can make to make a mask for myself that doesn't collide with the glasses, and it's more easy to take on my face for more hours. So my glasses just go here, so I'm avoiding this part on my nose. And just a test, just to see what happened. And then other data set we have. I have a smaller data set, so with reduced image size. So the first one was 5,000 pixel. with the Visual SFM was taking a lot more time, so I made a smaller one. And then I have this dataset, which is on my hand, and I've drawn a lot of different features because I want to be sure that the area where I've designed this shape, which is like a brace, this is where I want this brace to be, for example. So here we can put a strap maybe, and here another strap, and here another strap. I don't know. And I don't know what this kind of brace will be useful for, but it's kind of very common kind of shape. Probably not designed well because I'm not a doctor. And another dataset, I just found it yesterday. We can probably use that for the 3D scan part. It's a 3D scan that is done by this 3D Scan LA studio. Let's see if we manage to find him. Scan LA, let's try like this. Okay. So it comes from this Photogrammetry studio. It's actually a company that does just that. And they can rent you their photo box, which is this kind of very big structure where you have like thousands of SLR photographic machines. So those are the EOS, the Canon EOS Rebel. So it's actually an entry-level camera. So it's not the professional camera from Canon. And it's because they're using thousands of them. So they need to be not that much expensive. But still, I think it's €500 camera. So it's pretty expensive to make this machinery like this. And the camera are not in a fixed position. So they can modify the angle of every camera depending on the scan they're doing. So it's still a pretty time-consuming operation. The big difference between what we are doing here in OpenDot with Photogrammetry and this kind of setup, it's all the photos shoot at once. So you have a scan that is done exactly in the same moment, okay? So all the cameras shoot together. And that's a really big difference in the quality of the data set. So if you have an object that it's always in the same position while you're doing your photos, will be much better. Because if you have any tiny movement in the person while doing the photos, this will be an error in the photogrammetry, and so the software will not be able to align the photos correctly. If you're lucky, the error is very small and will be compensated by the other photos. If you're not lucky, the software will not able to put the different data set together. So the one where you are in one position and the other when you are in a different position. So it's pretty different way of making the scan. And they also have a shop for 3D scan. So they are using this kind of 3D scanning for making I don't know what exactly, but they have really bad taste 3D scan. And I don't know for what purpose they're using the shirt scan. The face is pretty. more obvious. Sorry?
It might be for rigging for the games or stuff like that.
Yeah, I think also maybe for that kind of situation. The face for sure, because they're making a different position and different expression in the face. So it's probably used as a reference for person making how you say object for games. So it's the data set. How you say that? I don't remember, Antonio. The
rigging is when you define
the way
the
where you
skeleton
move,
inside a
but
3D
the data that you put in a folder of a video game for making
the asset.
The asset, right? It's for making asset for video games, probably. And I don't know the others. Like, this is actually made specifically to be an asset. So when you see person in this strange position with the hands like that, it's because it's the easier position for making the bones, the virtual bones inside, and then be able to move them inside a video game or whatever. And so they make this kind of 3D scan for this purpose. By the way, in the medical field, maybe it can be useful to have a rigging, like a camera rig, like the one they had, maybe smaller, like the size of an arm of an egg of a leg, for example, in order to make this kind of 3D scanning faster. But the other main problem it's how be able to let the person keep the arm or the feet in the correct position. So this is another difficult topic for the 3D scanning. And so with the tomography, they are using some kind of fixture that holds your head still while doing the tomography kind of scan, because the tomography can look inside those kind of features are made of a specific density that can be later ignored by the 3D scanner software. So they're like making something to keep your head like this, or you can make something that keep your hand steady in one position during the scan. And so this will be another difficult topic that we need in some way to fix. And another way to make 3D scan Arctic.
But there is no technology between photogrammetry and tomography. Photogrammetry is based on the picture, and like LiDAR is based on the timing of the light. There is no like a machine that make you measure the time of the light or something like that to make a scan or of just the exterior and not the inside part.
Like time of flight, it's not the technology used on tomography. So I don't know if I understood well the question. So tomography and CT scan or whatever, they use or magnetic field or other stuff that sees inside you and makes some reflection, or also it's possible in some way, I think, to also get a scan from ultrasound data. I think there is a technology that can do that in some way. But if you are using standard light or like infrared light, that it's the one that it's normally used on 3D scanning, you will not see inside the body. So you are just looking at the reflection on the outside. And So this will be a different way to see and different kind of applications. So you can use photogrammetry, structured light, and laser triangulation if you just need the outside appearance of the body and the outside shape. Okay. For all the other kind of stuff, it's better to use tomography, because you need to know where the bone is to make an implant, for example. Sorry,
I understand that, but if I just need the outside part, photogrammetry is one of the best one. It's not that you use like LiDAR or something other technology to.
It's not one of the best. So I think the most common use on medical kind of operation, it's scanner similar to RTEC scanner, which is actually structured light, maybe mixed with some photogrammetry inside. So they're kind of a blend of different technology. And they have like 3 or 4 photographs taken together with some pattern on top. So they can see both the texture of the person, then the projected pattern, and so on. So they have both the data set we are using on structured light and photogrammetry kind of data. And they can also use robotic scan, because the problem with this kind of scan, it's they are handheld. So they're taken from one person, and that it's doing the scan around you, okay? And when you do this, you have always to look at the screen of the computer to see if the scanning is actually getting a proper scan. And because you need to move not too fast, because the scanner it's looking as photogrammetry is doing, to align the different scanning you are doing real time, to align them. Okay, so the scanner also usually has some accelerator, like a sensor that it's feeling acceleration, like the smartphone you have, in order to guess where you're moving. Then it's looking at the photograph it's taken to be able to put the different scan. Let's say it's taking 1 scan per second. Okay, so it's making real time the scan. So it's taking maybe just this side of your face, and then the scan is moving a little to the side, and it's taking another scan. So you need to put all this scan in real time together. Okay, so it's really complex from the point of view of who is making the 3D scan, and it's really easy for the user at the end. So you just need to go over the person, see if the scan is properly aligned. If they're not aligned, will become red in the screen, and then you go back a little and make more detail in one area, and then you continue moving around the people, and you're making the scan in real time. So it's really easy, and will be in some way accurate as the photogrammetry. It's not said. Maybe you can have some pretty good photogrammetry that does a better job. So it really depends on how you are making the scan, which technology you're actually using, if the 3D scan is good or not, if the 3D scanner software is good or not. So the quality can vary a lot. So it's really up to the machine and to you if you are making a good stuff or not. So with photogrammetry, you can get pretty close to this kind of machine if you do a really good photo set. Okay. So you can go really, really close, or even better in some cases. but probably on a medical facility, it's easier to find this kind of scanner because are easier for the technician to use and quicker. So it's probably best way to make a scan on a medical place. Okay. So we can look back at the 3D scan I was saying before, the one made with a 3D grid. As you can see, we have a scan of all men, let's say, and it's really good data set. And I've already done a 3D scan out of it, so we can choose whether to use the hand lathe for the exercise or the scan, which are both good. We can decide together. And as you can see, this guy is the perfect subject for photogrammetry because has no hair. As you will see, hair it's one other of the tricky part for 3D scan because they're kind of fluffy stuff where the light comes inside, some part is reflected, some is not. If you look from a different angle, they will have a different reflection. So hair is the worst stuff for photogrammetry. Also Artec structured light scanning. So when you're doing scan of the scalp, if you look to other data set they're doing, when they need the shape of the head, they always put like something over the head that makes the hair go close to the head. And the other interesting feature about this guy, it's he has a lot of spot all around the skin, and this is another very good feature for photogrammetry. So people with a very bad skin, let's say for what you will see on commercial about stuff for face, creams and lotion and so other, will be really good for photogrammetry. So don't wash your face for at least 1 month, so you got a lot of noise, a lot of skin defect, and that will be better. If you have a very clean face, it's not good, so you will have probably to put a lot of marker on your face, okay? So will be better. And do not do like me, that I've chosen a random pen inside the lab to do the stuff on my face, and that stuff remained there for at least 2 days. So choose something carefully that you see that it's easy to clean later. I've tested one time the Kina marker, so the one made for making like comics strip, the Kina ink. It's really good to clean, really easy to clean, and it's really natural. So I would suggest that, but test it before. Test if you are allergic to that, and so on. So a tiny of a disclaimer. And that's it. We can, as you can see in this data set, it's not easy to see that the photo have a very tiny angle one to the other. But if you look at the folder and you select, for example, the image that are from covering the face, you will see that the angle one photo to the other, it's pretty close, okay? They are both made from the side, from the top, from the bottom, and you will need to cover these in the same way on your scan. So what you do usually to have like a reference, you usually do some like here I've made 2 ring, like we will see that in the software later, because we will see the camera position where we'll do the scan. And I've made two rings, one a bit higher and one a bit lower. So I'm moving, Alberto was moving around me and taking photos each step. And each step he was taking a different photo, and then he made another turn from a different angle, okay? So this for the face is enough. For making the scan of the hand, you have to be careful to take photos of each angle to see the area where you need to take the scan. So another reason I've drawn all over my hand was to have reference for Alberto, who was taking the photo. And I told Alberto, just be careful of the area where I've drawn the marker. And if you see, all the photos are taken as close as possible to that area, because we just need that. I don't want to waste any resolution of the camera, so I just cover that part. Okay, so and all the photos are focused on that area there. And then this part of the scan, it's in order to get this area here, okay? So we need at least 5 photos with the same details to get a proper scan. Okay. So that's it for the photo taking part. Another thing is, if you look at this bunch of photos, you can see we have made a mistake in the camera setting, because those photos have a different exposition from this. This can be a problem for the photo alignment, but it's also a problem for the aesthetic perspective, because when we will make the texture for the object, that for our class today, we will need that, but not too much. The other problem is that the texture, it's not aesthetically good. So if you are planning to make the scan for making like an asset for a video game, you need to make a good photo exposition in all over your object. So it's better maybe to stick to manual setting while doing all the different photos. Keep always the same focal length and stick to the same setting for all the data set. The only thing that you need to change from one photo to the other, it's where you focus. So the focus obviously will need to change to cover all over your object, okay? And the other problem we have on this data set, in some photos where we have this angle, for example, as you can see, this part is not on focus. So if I'm doing this angle, in order to get this part right, I need to focus a bit better on this part maybe, and leave this other part less on focus. Okay. And last part about the dataset, it's not easy to see on this photo. I'm standing with my arm put on two places where to put in rest my, I don't know how do you say this in English. This part and this part are put on something that stands still. So the background and this part of the photo are always well aligned. So I need to not move compared to the background, okay? And the other data set where I was doing my head, I was standing to the wall, so I was more able to keep my head still during all the shooting, okay? So you need to be really, really careful about that. If you shoot the person with the arm inside, like in the air like this, the arm will move constantly with the background. So you need to mask the image later, okay? And the other stuff you need, it's not to move the object with themselves. So this will be another error if you have some photos like this and some photos like this. Try to avoid every kind of movement during the scan. Okay, for the photo part, it's finished. We have still 2 hours, so we will make a break right now, and then later we will go pretty fast with the 3D scanning software, because actually it's easy, and I prefer to go further with the modeling part, that you will find a bit less tutorial about how we are doing stuff today. So you will find also a lot of tutorial about Meshmixer, but we are trying to think about how to model for a medical kind of object. Okay. Any question, or you prefer to make question later if you're tired?
Actually, while this is very in topic, I heard that you were talking about the Artec EVA scanners. And I recently, I'm involved in a project. We did the scans with the EVA scanner. And the main issue was, like, we were scanning the hands, and because we're doing the 3D printed casts over here. So it's basically, customizing orthotronics. And the main issue was, for example, this finger. So for example, this finger was moving. So it would layer down everything like this. And I was thinking, like, while you're doing photogrammetry, you can only see the final result once you do the point cloud. So how do you guarantee that you're not moving? Maybe you have like a structure or a holding or whatever. Because while doing the scanner and seeing real time, we could see the results that, it's not working. Okay, redo. So how is it in photogrammetry?
That's a problem, actually. And I want to show, I'm looking for a folder that I'm not able to find at the moment. Let's see if I still have it here. I will bring that later, maybe, or maybe I can find it on Drive. So during the this 15 minutes, I will look for a different data set that I think I've put on still on the website, on the Dropbox file. There should be Miriam dataset ARM, something like that. We have made like a holder specially made for that. For the finger, I would recommend, if you need the scanner over here, maybe the best thing is to design something to hold the finger together, probably. And in that kind of scan, we choose a place where to put the arm to rest that we didn't need, because she was designing like orthotics that was not going to this point. And so probably we have to design something to hold the person still. The other way is just to make a 3D scanning rig with a lot of cameras and take them all at once. That should be always the better solution, always. And also with the Artec, it's a problem if you move, as you said. So we need to find probably the same solution. With Artec, you can correct always later, but will be still a problem if you're moving.
Not always.
Not
Sometimes
always.
That's up so much, you just start everything over. So I was thinking, the thing costs like 13,000, and it still results in so much noise that you have to repair for half a day. So it was a bit annoying.
All think about that all 3D scan have different problems. So you're just choosing
which problem
you want to deal with it. Okay. So it's
sorry, Tiziano. Mattia, which is actually participating in this call, is actually is the guy that made the previous year the scan for Rosina's hand. So Mattia, if you're available, if you want to talk about it.
Mattia Ventrella or
Mattia Ventrella, exactly.
Okay.
but I think he's not
It's
listening.
not here, actually.
No, yeah, I'm here. Yeah. Now, with Rosina was difficult because there was more or less the same problem about the hands, about all these steps of scanning. So we decided more or less to follow a different path in order to thermoshaping all the things after the 3D printing process over the hand of Rosina. So for that specific reason that the scanning part was not so clear, the time was not so long in order to have everything perfect for the second part of 3D modeling. And in that case, with the FDM 3D printing, we did something different. So we try to invert completely the process.
Okay, and so what I was saying, if I understood well, it's you molded the 3D printing on the person actually at the end, if I remember well.
Yes, yeah. Exactly.
So this is like more classic way of working for the medical person. So it's when the traditional operation, and also TOG, the foundation we are working with, still works that way. So they make a plaster on the body of the person because they know with the hand what is the correct position for example, if you're making like an orthotics for this part of the body, they are holding the child in the proper position while doing the cast. And so that's still probably the best way for doing this kind of process. And then they are 3D scanning later the cast, not the children. And then they modify the 3D scan and 3D print it. So, and this is the best way for them to do this kind of orthotics, because the orthotics at the end doesn't cost much because it's not made by a special lab that does that, but they do them internally with their 3D printer. So they're not spending money outside the foundation. And at the same time, the 3D printed orthotics are kind of lighter than the plaster and easier to clean. And this is another opportunity. So if you see that you prefer to work, for example, I'm doing a handle, I can use some plastic putty to make the shape of the person holding this putty. And then I can 3D scan the putty object, not the hand, if I want to do some ergonomics work, for example. And so it's plenty of possibility. It's better to experiment with all the system you can find and put your hands on of 3D scanning to see which one works best for a different kind of situation. And also know the tools you are using for make the model later, so you know which feature you can correct in the 3D model later, which not. So we're just doing a quick overview of different system, and but it's better to get hands-on them. In our lab, we have Sense 3D scanner, which is a very economic one. And it's 3D Sense scanner, 3D system maybe. It's this kind of scanner. So it's a portable handheld. It's the inexpensive version of Artec one, and it's like 300 euro. And we have it. It's really easy to use. You can come here, install the software on your PC, and get a 3D scan. And you will see, sometimes it's better, sometimes it's not, of photogrammetry. And it's not as cool as Artec, so this time probably photogrammetry will be better, but you can still get a 3D scanning and be able to understand the difference between this kind of scanner or not. So quality of the scanner makes a difference. So know that it's a really economic one. Okay, we can stop here. We can see in 15 minutes.
This scanner is just work on different paths, or can be a white, completely white, like your
Can be completely white because it's projecting, it's a structured light kind of scanner.
Okay, okay.
Don't expect if you have a flat object like this to have it actually perfectly flat on the scan. So you will still have a lot of noise on top of that. So every scanner has kind of noise problem, and you will still see that.
Model, or you do all the scan, and after you already have the 3D model, or you have to import all the data and...
No, you have already the 3D model at the end of the scan. So as you stop, you will you already have the 3D model. So it's like also less less complex for the computer to calculate the 3D model. So will be a bit faster than photogrammetry. If you are doing a really big project with photogrammetry and you don't have a good computer with a good graphic card, expect to leave the 3D scan for the night or for a few hours if you are doing a big one. On my laptop, which is 2 years old, but was a good one 2 years ago, for all the 3D scanning we are seeing today, I've took around 1 hour around of computer work for that. Can you see my screen with the... Okay, just taking this old data set we have done. Was one of the first scan we were trying to do for this kind of project. So this girl Miriam was doing a thesis about a special brace to make to be able to go again to make kick fight. I don't know the name of the discipline, and kickboxing. Sorry, and so she drew a lot of markers all over here, and also on the platform here, because the software we were using, we needed a lot of marker in order to get the first alignment, and we needed to do that by hand, actually. So we needed to align manually the point number 6 with the point number 6 on each photos. It was huge time-consuming operation. So it's something I don't want to do anymore. So I'm pretty happy that the software, photogrammetry software, have improved, and we have some of them that does this automatically. And by the way, if you look back at the photo I was using before, so the data set of my hand, so what's this one? On the back side, I've put some marker with some number. This one, so 1, 2, 3, 4, and I have somewhere maybe. By the way, somewhere I have written which are the distance between all these points. So I usually use the bigger distance to get the first scale, and then the other one has a reference to check if I've scaled everything correctly. That's why another difference with the structured light Artec kind of scanner, it's with the photogrammetry, we don't get the scale. So in a photo, you cannot know if the object it's really small and really close to the camera, or really big and really far away. Okay. So you can have two different datasets that looks exactly the same with two objects that have really different size. Actually, it's possible. So the software never gives you the scale of the object. So we always need to measure some stuff in reality before getting the photos, or just after, before deleting the marker. Okay, this is another thing that I forgot to say before. And so if you don't do that, your data set will be unusable again. Okay. And so on the human body, it's pretty difficult to measure things. So I prefer to do that on the marker. You have to be sure that your software does also the texture or the coloring of the mesh. Because again, if you draw something on the hand and then you don't have the texture at the end, again, you won't be able to use the 3D scan anymore. So know about that, and we will see in a moment how to scale things up. So we are all set up. We have always, everyone came back, everything fine, make a sign. Okay, I can see some face, we can start. Okay, so what you will need now, it's Regard 3D. So this is just a piece of software about Regard 3D, which is just to check how it works. And we will use the Kermit dataset, which is a pretty small one, and I know that works for sure with this software. So when you open the software, you just need to create a project, and non ti preoccupare, vai tranquillo, fai pure. There was Mirko around me that was trying to avoid making noises. Okay, so this is the first thing you need to do. It's create a new project, so we call it Kermit. I'm placing this in the same project path of the photos, just to know it's there. I will select this, and okay. And then we just need to click on this button until we are done, because this will change anytime during all the different operations. And now we need to add the picture set. So we just go into the folder and we add the image, just the image, not other strange file that you may have in the folder. And as you can see here, the software already look for the camera model, image size, the brand of the camera, the focal length, which is really important because they need to know camera, the lens, and the focal length to get the distortion matrix we were talking about before. So for every camera model, there is like a correction matrix, which tell you this pixel should not be here if this was a perfect projection. Should be like 1 pixel dot 34 in that direction. Okay, so it's correcting and modify all the image in order to get a proper projection. And I don't know which other stuff it's looking for. So, okay. Then change this button. So again, compute matches. Some number we don't need to change for the moment. Computing matches was successful. So what was doing here? So if we click on triangulation, show matching result, we can see actually what photogrammetry is doing. So we have 2 pictures. We can show simple key point. So are the main key point used for alignment. So we can see, for example, this pink dot here it's the tongue, and it's matched to this key point here, okay? And again, all the key point, also points that you would not have choose as a person, because the software use a different kind of algorithm that your mind, so it's more machine-based kind of key point. But you can see all of them, it's matching one point, one image to the other. You may see some error, and if you find some error, it's probably because the next step will fail. So if you don't get a proper result here, it's probably, you don't need actually to check them. We just run into the next triangulation part. So the triangulation is the part where the software, knowing all these matches between the photos, will try to say that if I have this different point and in the other image they are kind of deformed, the position, that means that I have an angle between those two images. So it's trying to guess this angle and the different position of the camera in the space. So what it's doing right now, we choose to use the two pair of photo with the highest matches to make the first guess. And then we will start to construct all the other guesses starting from those two pair, okay? And this is the quickest way to get the result. You can also use other kind of algorithm, which try, for example, the global structure for motion is trying to guess all the photos together. So we'll take more time and probably with a better result, but I don't know, because I don't know this specific algorithm. So we can start with this. It's doing its stuff, was really, really quick. This is really, really quick because the photos are not so many, and the image are not so big at the end. I don't know if you can see that, but there are some points here that I barely see, so probably you don't see them, but are not so many, and they are the first matches. So they're just the matches of the point of the key point we have seen just before. And now this button changed, we can create a dense point cloud, which is the first step of creating the 3D model. Also, another number of stuff we don't know, and I don't know, and I don't touch, I just click next. And but those are kind of deciding the quality, the time, and all the fine-tuning of the algorithm. So you can try to change them if you don't get something which is good. So now it's making something more. I don't know if you see anything. Maybe I can increase a little if there are some settings for the view, maybe. No, I don't think I have any chance to polygon mode. Point size. Okay, now it's better. Now you can see everything, right? So as you can see, we have a first glimpse of the 3D model. So those are the point from where the software later will reconstruct the mesh. So as we can see, there are not so many. If you use a higher resolution data set, will be much better. I've tested a few images of the data set of the old man, and they seem to work on the software. So you can try them later if you want to test the software a bit more. And now we create a surface starting from this point. And again, I don't touch anything on this. And that's it. This is this not so good 3D model, but with some colors on top. So it's with some kind of texture. This is not actually a texture over the 3D model. It's just a coloring which is applied on the vertex. So we started before with I don't know if I can show that back. Not the 3D point, but starting from this, when it's doing the 3D model, we'll assign a color of the vertex based on the color of the closest point that it's on the point cloud. So it's just a coloring doing on the mesh. It's not a JPEG over the mesh. Okay, so it's kind of a bit different. So if we wanna go back to the surface, I can go here, option, file, export surface. Sorry, it was here. And we can export it into Ply or OBJ format. So OBJ can go directly on Meshmixer later. And we can try also the Ply format. So we already saved the OBJ and we saved also the Ply. Okay. Okay, and we can go back to our folder here, and we can see that we have an OBJ file that we can open on Meshmixer. And as we can see, we have our 3D model here without the color, because Meshmixer is not able to render the vertex coloring coming from a different software. It can do that inside the software. But can show the texture. So later we will have some model with some texture on top, and with those we are able to see also the texture. We can try to measure our 3D model in Meshmixer. So we go to transform, and we see that our 3D model, it's 2 millimeter and 0.5. Okay, the whole 3D model, one of the dimension. So it's for sure out of scale. So a chair will be 500 millimeters, I don't know. And this is just 2.5. So the scale is completely random. So we need to adjust that later. Okay, so with the regard 3D, I don't know if we have the option to change the scale. Probably not. So I've made also the tutorial for MeshLab. If you need that, you can use that to change. I think I still need to install MeshLab. You can use that to change the scale, because on MeshLab you will be able probably to use to see the texture, and so also seeing the. No, we already have it. Okay, so you just need to open. Okay, this is a MeshLab interface, and we can open this Ply object. We don't have the texture also here. So regard 3D will export the mesh, but probably not the coloring of the vertex, because MeshLab it's pretty good software, and we should be able to see the coloring. We can see a bit better the mesh, which is not so high resolution. So we can barely distinguish the head of Kermit here, the arms. And of course we have some dark spot, because they were not included in the photo set. So if we have an object with this kind of complex shape, we need to go inside here and be able to shoot some photos of this area. Like we could do some photos like this, and then like this, to try to get most of this shape. It's enough to make some more. Sorry, I'm just okay. So on this kind of part, we can make some photos that have a very small angle one to the other. So even if we cannot see the difference between different photos, the software will understand that there is a parallax and will be able to reconstruct the 3D without many problems. So if you have this kind of very tight situation where you cannot take very different angle here, you can stick with kind of lower angle in order to get that part correctly modeled. On MeshLab, we can make the measure. For example, if we know the distance from the mouth and the leg, for example, we can go here, see that the measure it's 1.22, then blah, blah. And we can just open a calculator and say, oh, these measures should be 200 millimeter. I can divide this by this number here, which is the actual dimension. And so this is, no, sorry, I put the wrong number. 1.22743. So we can say that we need to scale it up 162 times. Okay, so it's not 160%. It's actually 100 times. Okay. So how we do that? I usually, sorry, I've closed the calculator, but I remember was 160. We can do that scale up. And on MeshLab, I need to close each tool I'm using before using the next one. So I go to scale, and I can press T to translate, R to rotate, S to scale, and just hit S, and I scale on. I can see that the object is moving because it's not on the center of the origin. So I need to place it before on the center of the origin, and then I can scale it up without the object to move, because it's moving compared to its origin. So when you scale up from the origin. So in order to make this, I can go outside this tool, show the axis, so I can see that my origin is actually here. It's not this ball. So I can hide the trackball, which is kind of confusing the first time. Then go back on manipulator tool, and it translate, and then I can move my object to the center of the origin. And then I hit enter, turn exit from the move tool, then I can turn around from another view. Go back inside translate tool, move again, and we put it here. The difficult thing to understand in MeshLab at the beginning, it's we are making a matrix transform, which is a kind of mathematical operation of moving things into the space, changing the location of the axis, which is temporary. So if we need to apply the transformation, each time we have to go here and say matrix freeze current matrix. So we are kind of applying the current matrix and say, this is the new position of all this bunch of points. So it's a bit confusing at the beginning. By the way, you have the full video tutorial on how to make the scale and how to make the point cloud on MeshLab. So I don't want to waste much time here. the only thing I'm saying is if you need to work on point clouds, which was what we were talking before. So you got a scan of a building, you got a bunch of huge point clouds. You can use this software to align them, make a noise removal algorithm, remove points that has a bad quality compared to others, and make a bunch of a lot of filtering and have a huge amount of really good mathematics inside this software. Okay, so keep that software in consideration every time you need to do something which sound difficult on meshes, point clouds, whatever. So if you want to 3D scan, it's we are seeing some strange images from Andrea Valli, that was closing, and so it's a very, very good software to have in the 3D scanning toolbox. Okay, so we can close this and go to 3D Zephyr. So for the guys with Windows who are lucky to have Windows today, you can open the software. We'll spend just a bit more time on this because it's kind of a bit more interesting. We can do a bit more stuff with this. So if you have the software open and you have downloaded some of the dataset, I think the best one it's to use the one with my face because it's the easiest one. I'm still opening the same folder again. I kind of distract this one. It's the good one. So if you open Tiziano face full dataset, we can try to choose just 3 photos to see what happened. Because first time you start with photogrammetry, you can use this amount of photos and probably will be fine for the first scan. For very, very simple scan, as a face can be enough. I can choose the center one and the 2 photos that are on the left side and right side. Maybe the one front a bit more from the bottom, which is also a useful one. And we can try with this just 4 photos to see what happened with the 3D Zephyr. At the beginning, you will have to close an interface that pops up. And just after that, you can just drop the photo inside. Okay. So the project wizard will guide you to all the steps needed to get your 3D model. So if I want, I can just click on check online for pre-computed camera calibration, mask image if I need it. We will see that later was the masking part needed if you have shooted like one arm just inside the room like this. And I need to get just the arm because I know it moved around during the photo shooting. Or if I have an object and I just shoot it like this, just turning the object around without the background to move, I need to also to mask the object. Okay. And you can do that inside Zephyr, which is pretty convenient. And I can just say, compute the 3D model, compute the texture, do all the setting and just launch the scan and come back in 1 hour, I don't know. A few minutes for this, just for image dataset. But we can do one step of time and just check for the computer camera calibration. We will do just the alignment of the photos. Okay. So we just make this step. Here we have a log of all the image. We can add other one or remove some. Then next, we can see that it checked online for camera calibration, and it found it. So it's already adjusted, and it's the model of the camera and the focal length and the number of pixels. Next again, and here we choose the preset we need. So preset means that we are working in easy mode. If you want, you can go also on advanced mode where we can choose a bit more what we are doing, or also on custom mode, which is just typing the number of each value we want to change. So I've never done this, so just preset are fine. So if we look, we have a preset made specifically for human body, and a preset that it's fast, one default, one deep. I prefer for the camera alignment, unless I have thousands of photos, to go with the default mode or deep mode, because the camera alignment, it's one of the most important part of photogrammetry. Because those photos are pretty easy to align, because they're almost the same angle, we can use fast or default this time. I think we'll take a few seconds to calculate. So right now we have a recap, and we can hit run, and it's doing this stuff. We have a log, and it's already done. So these reconstructions tell us that he managed to reconstruct all the image, and we are fine. If you see a lot of no, so it's discarding a lot of photos, you can switch back, like selecting all the cameras, say new project from selected cameras, and next, no, we don't save, next, and choose the deep, change the settings. So you increase the quality of the reconstruction. So it's looking for more details inside the photos, and sometimes you can recover a data set that was not correctly aligned and got it better. So with the data set of my hand, the one with the all drawn stuff on top, was not able to align one side to the other, because there are not many photos from the top. So default was not enough to get the proper alignment of that part, so I had to switch to deep alignment to get it better. As we can see here, we already have some point on my face, which is this part of the point cloud, some point on the wall with the shadow of my face, and here not so visible. I try to change the settings maybe to make them more visible. Export.
So also for the background, it's better to don't have a white background, but have a background with texture or something like that?
Yeah, it's better if you manage to stand still to the background.
Okay.
If, like in the case of my arm, I've tried to look to all the key marks took around the photos, and the photo was so blurred that actually he wasn't able to get key point from all the background around me. Okay. So in that case, maybe it was better to not have them, because probably I moved just a little with the hand during the shooting. So it depends on if you have a setup where you are able to not actually move or not. So it's better usually for objects that are still to have a lot of texture details and so on to make the alignment better. So we can increase a little the sparse dense cloud size. There should be also the camera side somewhere. This is one, the rendering part. Camera's scale, okay. This is the scale of the cameras. Okay. Make them also lighter. Okay, so you can see better here. We can see those are the angles of the camera, right? You can recognize these cameras here. So this is the front, it's this camera. And you can click on the single image to see actually that the point cloud, it's generated from some key points around here, which is probably the area where there is most focus. Was not taking anything from the eyes, we can see, because probably was too shiny and difficult to extract some key marks around there. So mainly was my forehead and my cheeks that was working in the reconstruction. Okay, and you can see there are some markers near the marker I've done. So those was probably used as key point. Okay, so then we just follow those 3 buttons here, which is we have already done the first step. We make the second step, which is 3D model generation. So this will do both the dense point cloud, then the mesh. And we choose to make the texture later, because I want to edit the texture a bit more. So we can use default mode or fast mode if you're working with more than 4 pictures, and also default for the other settings. Next, and run again. So as you can see, actually photogrammetry, it's, if you know the step of the software, it's can be really easy. So it's just clicking the next button. But will work or not depending on the quality of the photo data set. So it's the main problem, it's always there. So you have to test it and see what it works and find solution and test it and test it and test it until you learn how to shoot proper photos. Depending on what you're doing. So if you're doing a building, will be completely a different setup than doing a hand or whatever. Also, if you're doing a building, you still need something to reference. Has a sides, so you can measure one side of the building to get to the other one, or you can measure a window or whatever. So now it's computing. It's if we read the log, we can see a lot of information on what is doing inside the kernel of the program. So and we can see also what we are using in different step of the process of the CPU, GPU, and so on. Finish. So this is my face with just 4 photos, okay? So if we look at carefully at the mesh, we have some button on top to show better the quality of the mesh. We can see it's pretty high quality, but so it's a really dense mesh. But at the same point, got some mistakes somewhere. So my nose, it's completely chipped off in on a point. So it's not done correctly. Probably because in those 4 photos, there were maybe some kind of defect in there. I can see that it's the point where there is the highlight. So again, shiny object like my nose, it's not fine for photogrammetry. So it's better if you cover your face with some fine dust as the one for makeup in order to make it less shiny if you want to have a very proper scan. And other points where we can find some mistakes, it's because I didn't shave completely. So around where I have the birds, it's like there are some points that are not flat, that are kind of coming out from my face, and those are actually the single part, the single piece of the bird. So the more photos you got, the best quality will be up to a point, but then will be probably an overkill. So for this kind of stuff, pretty easy one without underhangs will be fine just to use for photos. So you can start with a very small project and see how to tweak them correctly. So you can see to make a very tiny angle between the photos, see if a bigger angle works better or not, and try to find the correct settings. Okay, we are kind of running out of time, so you can open, you have a full tutorial on how to make the scale. So we just measure as on MeshLab and find a proper scaling for it and so on. Last step of this is to make the textured mesh. So this software, right now we are using still a point cloud, a vertex coloring. But on this software, you can also compute the real texture, which is much nicer to look, because you can have a scan with a very low resolution with a high quality texture on top of it. And you can do that pretty easily here, because you can do some filter right on the mesh here. You can decimate, retopology, you can modify all the mesh inside Zephyr, and then run the last step, which is texture mesh generation. So you can modify all the mesh and then make the texture on the correct mesh. And this will be the best way to create, for example, asset for a video game. So you want a very low poly mesh with a very high quality mesh, okay, a very high quality texture. And then last step, after you have the texture mesh, you can just export it. We need to create the last step before exporting this, so I'm not exporting this model right now. No. Okay, so in the Dropbox folder, you have also 3D models. We can choose to work on the old man scan, but maybe I'm looking for file size right now to see actually if that is not too heavy, maybe. So we have a medium resolution one, which is can be fine. We have also the scan of the arm of Miriam that we have seen before. And we have the scan of my hand in low resolution. Maybe it's better to start with this file. So if you can download that, we can use all the same one, because I'm pretty scared that the old man scan will be too high in resolution. If you already didn't download that, I don't know if someone can share the link, because I don't have it right now at the moment. So if you have it, just open, you can share it on the chat. And by the way, I show you the scan of the man. As you can see, I have an OBJ file, but with the same name, I also have a MTL file, which goes exactly with the OBJ, so it's exactly the same name .mtl, and also a JPEG that it's down this way. So as you can see the face, some part of the neck, the skirt, and it's pretty strange kind of image. This is a good one because it doesn't have too many blank space, but you can see there are some parts that are not used. So the software is just unwrapping some part of the mesh, and it's projecting from the cameras directly on the mesh to see where to place the texture. And we can open this for a moment just to see that. So this is how it will come out. So as you can see, we have a very high detail texture. Okay, that's why the photos were really good. Okay, but if we look with the wireframe, we can see that I exported a really low resolution mesh. Okay, so the fine detail you are seeing, it's not actually on the mesh, but it's more on the texture. Okay, so here all these fine details that you can see of the skin are not actually on the model, but bigger details like the ear or whatever are done really well. We can see also a little of the inside here, but don't be fooled by the texture because most of the details actually are not there. Okay, maybe also this model is workable. I was planning to make like a collar, I don't know how to say, a neck brace for keeping the head straight when you have an injury. That is something that I was told that it's already been done in the hospitals with this kind of 3D scanning and 3D printing techniques.
We don't have to repair the mesh when we open from Zephyr?
Actually, this part we don't need to be closed. So it's perfectly fine like this. We just have to repair that if we have an hole in the part we are working on. So if we are making a mask, we will just care about defect in this area. So compared to other software, we don't need the model to be watertight and closed, unless we want to 3D print that. So in the Alberto lesson, the one on 3D scan for surgery, we need to 3D print actually the organ. In this case, not. We need to just model on top of this. Okay. So you have already downloaded the wrist, the hand low resolution, right? So you can just drop the model on top of the interface. I'm sorry. First thing, I just I check for. Okay, it's fine. No, yeah, we can start with this. So if you already had another model, you can choose to put in the same file or replace the file. So I just replace it right now. And we can check right now the scale as the first thing. So I don't have the numbers right now, but I remember was around maybe 80 millimeter from here to here. And so altogether should be around 180 millimeter, maybe. So we can go to edit, transform, and see the scale of it. So this is 1/10 scale, so it's 20 millimeter, okay? So I already done the scaling on 3D Zephyr using this chew marker, but now I need to scale it up by 10 times. So I just go with my model to edit, transform. On the bottom part, I have a sizing X, Y, Z. I just click on uniform scaling, and then I just move the the point to the end. So it's 2004 was .04 if I don't remember bad. And click enter. So this is 10 times bigger. Okay. The only problem with the Meshmixer, it's taking the scale of your object at the beginning, and it's adjusting all the tool to that scale. So one boring step we have to take is to export our mesh out of Meshmixer and then create a new file with the scaled one. So it's pretty annoying. So with the scaled version of it, we need to go to File, Export, and desktop, just export it there, and OBJ format. I choose the OBJ format, the first one, because the second one will remove the texture. So I prefer to keep the texture together with the file. So now I close Meshmixer, go to my desktop, and I look for my tree file I have over there, and there is still the texture, and I just open the OBJ file again. This is because all the selection tool, so the size of this selection tool I'm using are decided with the scale of the first object you import into the scene. So we need to import that back to make changes to this size of the brush and so on. So the basic step we are doing here, it's first thing we check that our mesh it's placed correctly compared to our planes. I usually do that looking this red point that you can see when you have show grid activated on view. It's the origin of the file. So the origin, it's already on the center because I've put that there on Zephyr 3D. And the other way I can look there, it's interbed that has the origin on the center. So I prefer to put the object midway to this printer bed. So this printer bed, it's around approximately 400 millimeter by 200 millimeter. Meshmixer, it's done for 3D printing, so its native unit, it's millimeter, and we need to respect that in some way. And the other way I look for the origin, it's to put some plane. Like I put a flat plane here, I dropped it in this coordinate, but I changed the coordinate to 0, so I can see where is the origin plane of X and Y. And then we can show also the object browser, which is the only way we can see how many different meshes we have in our project. So we can hide this plane. And now that this is selected, we are just working on this plane and not working with the hand. So if I select this, I'm working on the hand and so on. So the selected one, it's the one you are working with, and the hidden one, it's the one that, so you can work also on a hidden object, but it's not convenient usually. We can also set as a target. I'm not so sure about what that means. It's probably when you attach stuff to the mesh, you're working with that. But anyway, we select this, we make a copy of this mesh, 3 copies, and we go to transform and we rotate the first one around the x-axis, so 90 degrees around the x. Accept, and the other one, again, edit, transform. We rotate 90 degrees around the blue axis, which is Z. So like this. So now I can see exactly where my origin is. And open again the object browser. I don't know why I close it. Select the hand, edit, transform, and we can put it a bit more on the middle of our origin. That's not completely, that's not needed actually for work on Meshmixer, but will be a very nice feature if we want to use our file also on Fusion. Okay, so right now we can export again. I need to select my mesh. Export again our mesh. And the same OBJ format. Save. It's better probably if I make a folder with. So this is our new file. And we can try to open that in Fusion also. So the next lesson that will be held also by Enrico will also show you this part of mixing between those two software probably. And it's very, very useful because you can model stuff that are not easy to do on Meshmixer on Fusion and mix them together. So what I do actually, it's designing all the complex organic part on Meshmixer. And then if I have some snap fit, some technical details, I model them on Fusion. And in order to do that, I need to import our file using insert mesh, and go to desktop, this one. As you can see, this mesh, it's a bit ugly still in some point. So these on my wrist are probably error due to my hair on my arm. And other one, the one on the bottom are here because I didn't took too many photos of the bottom of the hand. And this part, which was actually the part with the markers, it's a pretty good resolution. Okay, so it's not doesn't have too many defects or so on. So also this part, it's pretty good. So what I'm doing with this, I have this body that I can use to take reference, know if I'm placing one piece here and so on. And I can use this piece of these bodies to use them as Boolean operator inside Meshmixer. So if I want a hole of a specific size and a specific shape, I can model the inside of the hole, put it on Meshmixer and use it as a Boolean operator. So right now we are not doing this. We just keep to Meshmixer. We don't have much time right now. So always keep this open. And first thing, we need to check a little the resolution of our object. So we show the wireframe and we see that it's a good resolution mesh. Maybe a bit too high for some of the operation we are doing. So the first thing we want to do is to clean this part, the one we are working on, and to kind of isolate that surface. So we want to extract it from the rest of the surface, and we want to smooth it out the more we can, and then we can use some operators to modify that mesh. Okay, so what we're doing, first thing, we copy this mesh. So we go to the object browser and we copy that. And we hide the previous one. So we select the new object with the eye visible here, and we can call it smooth surface. It's better if you keep this object browser tidy to understand things better if you have too many files on top of that. So with this object selected, we can go to selection, change the size of the brush we are using. If it's too small because you have changed the scale of the object, you can also type a higher number than the maximum. So the maximum is 100. I think we can type 150 maybe. No, it's not doable. So you need to do the process of exporting and putting the part back again. So this brush is selecting just around a geodesic distance from the center point where there is the mouse. That's mean that this brush is turning around because it has this expand mode that goes like in the shorter distance around the object. So know that if you go like this, you're selecting also the backside part. Okay, so it's similar to a sphere, and it's not actually a sphere. With the control, you can deselect the part that we don't need. So what we're going to do now is select the part we need to make this brace, and then deselect a little the part we don't need. Don't care too much about the boundary of the selection, because we will modify that later, because we have a lot of automatic tool to refine a little the shape. And like this. So this is why it was convenient to draw the shape from the beginning. I'm kind of ignoring some part because I want to make a better shape. So we have already designed, but we can still correct some part if we didn't make a very good design in the first place. Okay, almost done. I just need the last part, which is a bit... Okay, so once you're done with the selection, you can do also just a random piece. Don't care to make everything right in this moment. So just follow the step if you are working with the program. So right now we have a selection, and we have a lot of editors for this selection. So we have some tools that are edit tools that doesn't need the selection, and if you click on edit here, you will lose the selection. So you need to click on Ctrl-Z to switch back to the selection. And with the select tool, you have some tools that are just available with the selection. If you need to perform the operation on all the file, you just can use Ctrl-A, Command-A on Mac to select everything, and you still have access to the same tools. So Ctrl-Z to go back at our previous selection. We have some modifiers that work just on the selection, so we can expand the selection. If you look closely, you can see. You can also use the keyboard on the Windows. It's the choose sign. I don't know the name in English. In Mac, I think it's dot and comma. So shift, comma, I think, or shift point on Mac. And Windows, it's open brackets, let's call it, and close brackets. So it's just that button or the other one. So this way we can correct the selection if we have been too small or too like close to the edge. I also use this tool if I forgot some points around my mesh to close the holes in the selection. So I can increase and I count how many times. So I just do that 4 times and then 4 times back. So it's a way to also, if you have some spare polygons around, to unify the selection in some way. And we have also optimized boundary, which is pretty different from smooth boundary, which does completely different stuff, and we will use it just after this. So first, optimize boundary. Optimize boundary, it's just selecting and deselecting stuff on the edge. So if I have, let's say, some polygon like this, and I go to modify optimize boundary, they will probably, no, it's not doing anything on that. It likes this kind of shape. Should actually be changing this. So let's try with some, I don't know, stuff like this. Modify. So as you can see, it changed a little the selection. So it's making it a bit more smooth. By the way, it's not smoothing too much the selection. So we need also to correct it manually if we have done something that it's not so good as this selection. So we can correct it a bit more. I remove this polygon. I don't want to be here, and maybe add a bit more here. Okay, find this way, and maybe here we can go a bit more on the inside. If you double click, you will select everything, as you've seen, and we are done like this. Okay, so right now, next tool, we are using deform modify tool again, smooth boundary. This time, this will change the selection around the edge of our previous selection. And it's actually moving the triangles on the surface in order to get a smoother finish, a smoother cut of our mesh. So it's not still perfect, but we have a smoothness control here, and we can increase it or decrease it. So this was the previous selection edge, and right now we can smooth it a lot more to get a very nice cut. This is a very powerful tool. It's not easy to find this tool on mesh modeling software. And we also have a preserve shape, which is relaxing or keeping the shape more close to the original surface. But for the moment, we will keep it like this. So we accept the editing. As you can see, we still have the other part of the selection, but now the edge of the selection, it's much more nice. And right now we can choose to delete the part we don't need. So we can modify, invert the selection. So we'll select all the other pieces, and we just go to edit, discard, X, or we hit catch on our keyboard, delete, and we just delete everything we don't need. Okay. So we already have the main shape of our brace, still with the texture of my hand, which is pretty creepy. And we can show the other mesh in any time. To see, I always keep the original scan over there. If the scan is too high in resolution, I make a lower resolution version in order to be able to work on that. But I always keep the file there because we still need that for modeling and to see if our brace doesn't go inside our skin. So in order to be comfortable, we should never go inside our skin. Okay, so I will keep that always there as a reference for make all the changes we need. We have the smooth surface. I will go a bit faster right now. So my standard operation, it's always to understand what I'm doing with this surface at the end. So I want to use one method which is the fastest way to get breathable surface, and I just drop a sphere right here just to see the process. So I will first select my object, make an offset of it, so to gain some distance from the original surface. So I will just move it a little bit to the outside. Then I can reduce the resolution a lot. And we can use reduce tool in order to get a shape which is with a lot less polygon, like this, accept. And then we have in edit one very cool feature, which is make pattern, that allow us to make some modify on the mesh using some different style of pattern. The one we are using now, it's just making the edges becoming, as you can see, we have also the bottom surface because I've made an offset. So we can go on this tool. If we have the two surface that doesn't touch, but they are part of the same object, we can separate them using a separate shell that is making two different objects. One is the inside and one is the outside. So this was the inside, and I just delete this. So I just want this and edit again, make pattern. So we were talking about this tool. If I want to make something like this on my brace, I just use this tool. I just need to be careful about the dimension of this piece in order to be 3D printable. So on FDM machine, we just need to, I think, use 3mm, 4mm around that in order to be printable. After the first operation, there will be a smoothing that will reduce a little the size. So I know that we can print 2.5mm, so I stay a bit higher with this. And we can just update this, see what happened. Will take a bit of time. One step that I've forgot, it's actually to save your file every operation you do, because Meshmixer can crash pretty fast on every operation you're doing. So it's really important to export your OBJ sometime to be able to import them back if you are deleting something, and to always save your file every 5 minutes. So as you can see, this operation made these sticks to join together, and there was a final smoothing that was creating this kind of enlargement at the connection. This is pretty good for 3D printing because it's not making sharp edges around this anymore. We can also run the same stuff we were doing before, so we can make a big smooth after this in order to get this curve to grow bigger. So we can, as you can see, the smoothing operation, it's making some strange stuff, like increasing the inside edge and decreasing this part because they're smoothing and going a bit to the inside. We have some tools to avoid the shape to change too much. But Okay, I was pretty close to make the software crashes, so I saved my file on desktop.
You make an offset because, for example, for the arm, if you make this feature, the plastic go inside the arm, so we have to...
Exactly. So now we do the same operation on our brace, so we can delete this sphere we don't need anymore. Also the previous one, because some operation creates a duplicate of our mesh. So I want still to keep that smooth surface. So when we make the offset, first of all, I select everything and go to smooth this a little. So as you can see, the smoothing is doing this kind of operation. Be careful with the smoothing because it can change the shape. So if you have a corner like this, we'll pull away the surface from that edge. Okay. So in some situation, you can create something that goes a little on the inside of the hand. So we have to constantly check. So I'm smoothing a bit more, accept. And the other thing I'm doing is reducing a little the mesh, because this is too high resolution to do the other operation we want to do. So we can, we are decreasing of 70%. Let's try. This is doing some bad triangles over here. We can still remesh in some point, but we will try with something less. Accept. And the other stuff I want to do before making all the other operation, it's showing that we can still model this mesh. So if we show also the other object, we can see that we have gone a little on the inside of the 3D scan with the smoothing operation. Okay, in some way it's fine because some of these points were probably just defects. But usually in this moment, I go to Sculpt. I select a tool that it's good for what I want to do, so I can inflate, move spikes. In this case, I want to draw a little because I want to pull out some part. You have the size of the tool you're using. This is, no, sorry, the strength. So we go pretty low with strength, pretty high with the size. So I just want to make a general modify to this. And I choose a fall-off which is pretty smooth. So this will be the shape that I'm pulling out in some way. And if I remember well, with the simple click and pulling out, Control Z, and this is to hide the strength probably. So I'm doing a bit less of strength just to sculpt it slowly in some way. It's taking a bit of time. You can choose to not enable refinement because this will change the mesh as you sculpt. Okay, so it's adding or removing polygons. And the other stuff, it's we can also with the, I think, control, we are pushing inside with the normal click we are pulling out. So with this tool, I can correct the mesh where I feel I'm going too close to my hand. And then I can, the best way should be to have it flush with these defects, just creating some space in some point that where I feel or where talking with the doctor, I think there should be some differences. For example, I've tested the brace made with this technique. As you can see in this point of my hand, which is this point here, the mesh is going down a little. and testing the brace, this kind of part that push in a place inside a kind of defect you have, they are kind of not so good for ergonomics. So I'd like to smooth this part out. So I want to pull it out a little. So you can modify the mesh whenever you like. And it's easier to do that before creating those kind of breathable structure. So this is the moment, and also before giving a thickness to our surface. Okay. So this is the moment where I correct the mesh. Just after that, we can do an offset. So we can go to select again, Command A, select everything, edit offset, and we want to make an open surface. So I just unclick connected. So we'll make a second surface around 2 millimeters in distance, let's say. So this will be the center surface of my brace, okay? Because later I'm doing like, this is the surface, I'm making an offset, and then I will increase the thickness of this, okay? So I need to move out from my hand of half of the thickness of the brace I'm designing, okay? Plus maybe a little something to avoid has to be to press too much on the hand, I don't know. Or if we want to put some lining on the inside, okay? So after we are done with this, we can accept the offset. And now I have a file with 2 different meshes. So I need to separate them. Again, I go to edit, separate shell. And after a moment, they should be 2 different files. Taking a little time, and hope does not crashes.
Because it was connected, even if we don't say connect, did you make it?
They're not connected. So right now I should see. I'm still thinking. I should see that there are 2 different meshes. They seem connected in some way, but I think they are just 2 mesh, one on top of the other. Okay, so this is the reason we need to save Meshmixer pretty often. I don't think it's crashing right now, but will take some time to think about that, and sometimes stuck into thinking forever. So if you see it's taking too much time, if you have saved in the previous operation, you can just kill the process, what I'm doing right now, probably. And as you can see, it's using almost all the memory of the PC right now, and not so much in CPU. So it's probably a bit stuck in thinking. So we have probably switched back. A lot of time. So basically what we are doing right now was just selecting, edit, making an offset of distance a bit more. Sorry, I was working on the wrong. So we are making this offset, accept, edit, separate shell, or we can make something which is a bit easier for the program to calculate. We can select a place and say expand to connected part. So this is not good. We just need to, because we're selecting also the bottom side. So edit separate shell. Hope it doesn't take too long. Okay, so this is the bad way of this program. So in order to keep everything pretty fast, you need to in some way clean the RAM while working. So the best way is to remove all the objects that are too heavy to work with. So if you're working with a full scan of a body, it's better first thing to select the part you are working in, decimate, reduce the resolution, and export the high resolution mesh. So you just keep that for rendering or in case you need. And when you are still with the same coordinate system as we are seeing with Fusion, you can always import the mesh back in place for further use later. So you will need to keep the object browser. Sorry, we can't work anymore probably with this program. By the way, killing it again. And we will do some radical remeshing before working this time. Okay. So again, now if I see I have this kind of problem, the first thing you need to do before doing anything else, it's edit remeshing or reducing, and make a mesh with a much lower resolution, so you won't have this problem anymore. Okay, do you have some question on what you have done? So while I show you the last step, if you have some question, we can make them now maybe. So I can let you leave in a few minutes, maybe. No one? Have you already tested a little Meshmixer and how you have found it? So it's software that you think can work for this kind of job or whatever?
I actually was fixing the scans with the Meshmixer also. My workflow would usually include like the sculpting. I would smooth the surface for sculpting. So because at some points you don't need to lose the information, and at some points you really need. For example, if you have little here or little gaps or whatever. So yeah, I did with Meshmixer, and I think it's one of the most efficient programs to do so because it's really intuitive and easy to handle.
Yeah. If you have problem like reducing the mesh as I'm having right now, we can still use MeshLab, which is another very good software, especially in terms of use of memory. So we'll crash much less than Meshmixer. So if we want to do this operation and we are not able to work on Meshmixer, we can still use that. And you have used it in some other ways other than we were showing in the tutorial, like making offset or Booleans stuff, or in your experience?
I would actually, because the scanner would lose some information, for example, holes in the fingers or some major gaps, and actually those scans would also be 3D printed to present. So basically, we would 3D print the cast and also make a CNC from the foam, all the hand.
Okay.
So I did also the sculpting because at some points you have to really recreate the fingers or the holes. So I went through making solids, filling the gaps, then 3D forming them again. So
okay, that's nice.
It was really like the virtue of imagination of how to fix the rough sketch.
Another nice feature we didn't cover in the tutorial I've sent you, I think you already talked about that, was another feature that it's Unwrap, which makes a copy of the object, which is the flat pattern of our brace. Okay. We have used that in order to make foldable braces. So you take the surface, you decide to For example, let's say I want to make something that wraps around my finger. I don't know, it's a surface that it's over here and over here. And I want to print it flat because it's very easy to thermoform object on using the 3D printers. We can do modify, invert, delete, and edit, unwrap this part. So we have the exact shape of this piece wrapped on the surface. This color you can see here are the parts that are mostly deformed when opening this part. So if you make something that it's not easy to unwrap, you will have a lot of deformation. This shape, it's pretty easy to unwrap. And we can choose between different algorithms to unwrap and so on. And I think that's it. Sorry for being so long on the first part, and we missed kind of little Meshmixer, but I think on the tutorial to have covered pretty the main issue of working with that. And I think that's it. You have a further question on the stuff we were doing today?
I have a maybe stupid question. If you want to do a support for your hand, for example, to have the fixed hand, if you do transparent material, is for example to make all the photos around.
Mm-hmm.
You can do if, for example,
it's not a stupid question, but
light will reflect or.
Yeah, but transparent will not be invisible, so it's still changing, making reflection and changing. You cannot pass through a transparent object in a straight way, as it was invisible. So at the end, it won't change anything. I think the best option is stick to pretty small support. So in medical facilities, they have some structure that are used flexible structure that you can fix in very rigid structure that you can use probably to fix our head. Also, the camera we are working at right now, where you can see me, it's fixed with a strange tripod that has a movable arm that you can use to make support to help the people. Or in the Arkham tutorial, the software, the 3D scan we were looking before, they were deciding to scan the person just lying on the bed. But that was probably because they just needed from here to here with the 3D scan. So you have to decide depending on the scan you want to do.
Okay, thank you.
No one else? Everyone is really hungry to go to lunch.
Just one, and after we go to, I think I leave everyone for lunch. We design some strange 3D shape, maybe with the pattern, etc. How do you print these with 3D printer? You use
actually, I don't have a photos nor the piece right now, but it's doable with support. If you are in a medical facility with some more professional printer, probably you have the FDM machine with the removable support, so you can print them PVA and then be happy with it. And with our machine, we don't have the dual material machine. So we mainly use removable support, and tweaking the parameters a bit, you can remove them easily. So for this shape, I will try to, for example, put it, I cannot free orbit right now. So this is the print platform. of our machine, I would try to transform this, to put it in a way where I can have the support just on this vertical structure here, okay, going to the ground, and then the object is self-standing. So I will be able to print without going over the 45 degrees issue with the 3D printer. Also, if I'm putting a lot of details like hinges, stuff and that, similar, when I'm on the last part of the process, I start to think, oh, this is a very complex shape. How can I put it into a printer? And then I will choose one direction and then correct a little the small details in order to make it more printable. So it's kind of pretty difficult at the end to actually get a correct 3D print for this complex shape. The part with the pattern, actually, it's really kind of not so problematic. So if we have this random polygon, like most of them are correctly aligned, we will just have some random one that it's completely horizontal, and that will be a bit more problematic to print with the FDM machine. But the FDM machine can bridge pretty easily if you have two parts, like a straight line between points. So it will be still something that it's still easy to print. By the way, other pattern, I'm trying to do something quick. We'll see if doesn't crash this time. So we are doing something with a normal offset, like something this thick, and accept. No, already crashed. Okay, done. Done with the Meshmixer. Okay. So what I was saying, a lot of patterns are more printable than the one we were looking. So the one with tiny holes with the cylinder that are cutting through the surface, I think I've used them in the tutorial, are kind of easier to print. So there are a lot of solutions to look for printability. So first thing you need to know for who you are doing your project. If you are printing with the 3D service online, you will have a lot of, for example, so professional 3D printing are much easier to work with, has a easy to manufacturing shape. So if we look to materials here, so the printers that use powders can make a lot of complex shape. The only problem you have to evacuate the powder. The laser sintering, it's the same kind of technology, just use plastic, not metal. Also, multi-jet fusion, it's a powder bed technology. It's like you can do all the complexity you want, and this should be also a pretty good technology to work with the braces and so on. And it's really inexpensive, so you can do a lot of stuff with that. And the other technology is resin, which is a bath of liquid resin, but it's probably less used in medical part because the resin are not so good for skin contact. If you have a part of the resin that was not polymerized correctly, it will be pretty more harmful. And then FDM, it's usually done with support in professional 3D printers, so it's much easier to work than on open source one material 3D printer. Those were the multi-material I was talking before. So you have some composite material, flexible one, and one with grades of color inside. Okay.